Hey everyone, welcome back to another Photon multiplayer tutorial, and today we're going to be covering player controller instantiation, player movement, and syncing player movement between connected players. First things first, we're going to need to delete the demos folders from Photon. Because Photon already has a script called, if we go to add PlayerManager to our PlayerManager here, you can see it already has a script called PlayerManager, and we don't really want that. It's a lot of just extra junk in our game. So go over, find the demos folder under Photon Unity Networking and just delete that. And then go ahead and delete the real-time demos and also the chat demos. If you want to look at Photon demos to help you learn how to use Photon, just import Photon into a separate project and mess around there. So I'm going to add a new script called PlayerManager to our PlayerManager prefab, and I'm going to put that in my scripts folder and open it up in Visual Studio. Alright, so in our script here, I'm going to make sure I'm using the namespace photon.pun, and I'm going to make a new variable here, photon view, and we're going to call it PV. And I'm going to make a method, a wake method here, and in it we're going to assign the PV to get component photon view. I'm going to make a new function here called createController. And in here, we're just going to instantiate our player controller, and we'll get to that later. But right now, we can just put a debug.log statement there. In our start method, I'm going to check if pv.is mine, and if it is, we're going to create a controller. pv.isMine is true if the Photon view is owned by the local player. So as you saw in our previous tutorial, when we instantiated the PlayerManager prefabs, they each had different owners. So this will only ever be true for one of the instantiated player managers in our game. And now if we run our game, and start it, you can see in the console that we instantiated our player controller. So the next thing we're going to do is actually create our player controller prefab. Alright, I'm going to make a new 3D object capsule, and I'm going to call it player controller. I'm going to reset its transform, so we're at 0, 0, 0. And then I'm going to add a camera to it. And I'm going to make sure that this camera has a Y of 0.5, so it's in like the head position of our capsule. And then on our player controller, I'm going to make sure to add a photon view, because we need to have a photon view on any photon prefab we want to instantiate. And I'm just going to drag that into our photon prefabs folder and make it a prefab. Then we can delete it from our scene. So now in our player manager script, we can replace this here with photon network instantiate, and we're going to need to be using system.io again. Photon.instantiate path.combine photon prefabs and player controller. And then we can just spawn that at vector 3.0 and a quaternion.identity for now. But we will change this later and have it spawn at a random location. Alright, so now if we were to run the game, create a room, start it. You can see that our player controller was actually instantiated, and we're getting an error here. There are 2 audio listeners in the scene. That's because in our game scene, let me just go to that, we have a camera already in here, and on this camera just remove the audio listener. That's all we need to do. Alright, so back in our menu, I'm going to run it again. Create room, test, create room, start room. And now you can see that our player controller has been instantiated, and its camera is the one being used. So we're seeing through the view of this player controller, and that's important. Now that we've got the player controller instantiation down, let's work on actually adding movement and looking around with our player. So in our player controller here, I'm going to make an empty object. I'm going to move this up to the camera position. I'm going to call this camera holder, and we can put our camera inside of camera holder. Alright, so let's add a new script to it called PlayerController, and I'll move this into my scripts folder. Now opening it up in Visual Studio, I'm going to make a reference to our rigid body, which I'm going to add to our prefab now. Now back in Visual Studio, I'm going to make some new variables. Serialize field, float mouse sensitivity, sprint speed, walk speed, jump force, smooth time. And that's it for our variables we want to access in the inspector. Next, I'm going to add a bool grounded, a vector 3, smooth move, velocity, and a vector 3 move amount. And also a private float, vertical look rotation. Now in our wake method, I'm going to set RB to get component rigid body. And now we're going to start working on rotating our player. So in our update method, we're going to use transform.rotate vector3.up times input.getAxis raw mouse x times mouse sensitivity. There we go. And now if we were to, let's set our mouse sensitivity to something like 3 for now to test out, and then if we run our game now, if I move my mouse left and right, you can see that the world is rotating. Also in our game scene, let's just make a plane here and reset it and just move it down a bit so that our player doesn't immediately fall out of the world when we run it. Alright, so now if we try, then our player lands on top of the plane and doesn't fall. And if we look at our player in the editor, or if we look at our player in the scene view, we can see that using the mouse makes it rotate, and our player just fell over. So on our player controller here, let's actually go into constraints and freeze the rotation on the X and Z. And now our player should no longer fall over. And that is the case. There we go. These errors here are just random Unity errors. They don't mean anything. Unity just does that sometimes. Alright, so now our player can rotate. That's great. Let's also make a new variable. Realize field game object. Camera holder. And then our update method, let's do vertical look rotation plus equals input.getAxis raw mouse Y times mouse sensitivity, and then vertical look rotation, and let's clamp it at -90 and 90. Then we'll set camera holder.transform.local Euler angles to vector3.left times vertical look rotation. And if we run the game here, alright, now you can see that our player can look all around. Like so. Now, since this is all functionality for looking around, I'm actually going to cut this and put it in its own method, vector3 look, and then we can just call look from update. Keep it nice and tidy. Next, I'm going to work on the movement. Vector3 movedir equals new vector3 input.get axis raw horizontal 0 input.get axis raw vertical. And then we're going to normalize that. And normalizing it will prevent us from being able to move faster if we hold down 2 keys at once, like W and D. And then we're going to say move amount equals vector3.smooth damp move amount move direction times input.get key code.left shift, which will be our sprint key, sprint speed, walk speed, rest smooth, move velocity smooth. and we'll have to put this in parentheses. So this section right here is a compact if statement, and basically we're checking if we have the left shift key pressed down, which is our sprint key, then we'll use the sprint speed value times move direction, and if we do not have it pressed, then we'll use the walk speed value times move direction. And smooth damp will just smooth out our movement. It'll make it nice and smooth. Next we'll add jumping. If input.get key down key code.space, and we are grounded, then we will add force in our upward direction times jump force. And next we're actually going to work on the grounded state. So I'm going to make a new function here, public void set grounded state bool grounded, and we'll just set our local variable to that variable. Next we are going to, to get the grounded state to work, some games will use a raycast rate down to detect if they're grounded or not, but I find that doesn't work well if you're standing on top of a mountain peak or something, or if you're standing on a sharp point or an edge, and it gets really frustrating when you're not able to jump. So what I like to do is, on my PlayerController prefab here, we'll make a new box collider. So 3D object cube, move this down, and then I just want to disable the mesh render so I can only see the box collider. We'll actually just remove that, we're not going to use it. Let's set the scale on the X to like 0.6, 0.6 on the X and Z, and then the Y will be like 0.1. And we'll rename this ground check, and we can add a new script to it called player ground check. Alright, in our player ground check, let's include a reference to our player. And in our awake method, some guy yelling at people in my driveway. It's really loud. Alright, in our awake method, let's set our player controller to get component and parent player controller. Since this will be a child of our player controller, we can just get the reference to our player controller by getting the component in our parent. Alright, I'm going to make a few new functions here. Void on trigger enter, void on trigger exit, and void on trigger stay. Alright, and on trigger enter, let's set player controller dot set grounded state true. On trigger exit we'll set it false, and on trigger stay we'll set it true again. And in each of these we have to make sure that other does not equal. If other equals player controller dot game object, other dot game object. So if the trigger is our player, then we want to just return and not do the rest of it. So we'll add that into everything. Alright, now that's sorted out in our player controller. Alright, let's consolidate this into its own method here. Void move. Move that down. And then we can consolidate this into its own method. Void jump. We can add these all back into our update. With all that done, let's make fixed update. We'll say rb.move position, rb.position plus transform direction, move amount times time.fixed delta time. The reason we're separating some of the code into the update method and the fixed update method is because update is called every frame while fixed update runs on a fixed interval. It's important that we do all physics and movement calculations in the fixed update method so that our movement speed isn't impacted by our FPS. And now if we go into Unity, and let's actually set our movement speed here, so I'll do like 6 and 3 and 5 and 0.15 for our values. We need to make our ground check a trigger. And in our ground check script, let's make a few more functions. Void on collision enter, void on collision exit, and void on collision stay. We copy all of these. and just replace other with collision. There we go. Alright, so turns out 5 is way too low. Let's set it to just like 300 and try that. Some of these values will take a bit of tweaking to get them how you like. There we go. 300 seems fine for now. Alright, so we can move with WASD. We can sprint by holding shift, and we can jump with space. That's pretty good. Let's also fix the lighting in here. So in our game scene, I'm going to go into lighting, and I'm going to click auto generate. Just make sure that's checked. And now if we run our scene, we shouldn't get that gross kind of yellowish tint. We got a nice clean white tint. There we go. So now if we build the game here. Well, if we start this right now, we're actually gonna... Okay, and we spawned in. And everything is janky. And the reason this is because both of our players are actually controlling each other. So the way we're gonna fix this is in our player controller. We're gonna need a new variable here, Photon view, PV. And we're gonna set PV to get component Photon view. And then in our update function, we're going to say if not pv.isMine, we're just going to return. Yeah, not do anything. So now if we build, you'll find that moving our player, only one of our players moves now, which is good. But there's another problem. The cameras are synced up wrong. We're moving this player, but the camera being used is the other player. And that's a little janky. So it's not what we want. So here's how we're going to fix this. In our player controller script, in a start method, we're going to say if not pv.isMine, we're just going to component and children camera. Just gonna destroy that .game object. Make sure it's the game object too, because if you don't include that, it's only gonna destroy the camera and not the audio listener, and then we'll end up with 2 audio listeners in our scene again. And that's also the reason I didn't want to make guns and stuff the child of the camera, and why we put the camera under the camera holder object. Because we're just going to end up destroying the camera for anyone who is not the local player. PV.isMine can be a hard thing to wrap your head around at first, but after a while of using Photon, you'll eventually get used to it. Alright, so now if we build it, you can see that we control... There we go, we're looking through the camera of our own player, and we control with WASD, and if we switch over to Unity here, if I move, I control my own player. But the movement is not syncing between the clients. We can control our own characters now, but the movement doesn't change on the other person's screen. And the way we're going to do this is in our player controller here. All we have to do is add a new component called Photon Transform View. And then we have to make sure that in observed components here on our Photon View, we drag in Photon Transform View. Alright. Photon Transform View will just sync the transform of this object between clients. So if we run our game now, mind room test, just start it. You can see that if we move on this screen, our player moves on the other client screen too. And it's a little janky right now, and I will tell you why. Because we are not destroying the rigid body on our other player. So the physics are being applied on the other client too, and we only want to apply physics to our player on our own client. And that's what's getting this janky like rubber banding when we're jumping up and down. So on our player controller here, all we have to do is new line here and destroy RB. Now we can build. Getting an error here, and so as you can see in our scene now, the jitterness of jumping is fixed pretty much, but we're getting another error here, and that's just because we forgot to include this same return function in our fixed update. Now everything should work perfectly. In our game scene, we might as well add a few different cubes here just to spice it up a bit, make it a little more fun to jump around. And I'm also going to make a new folder here called materials. Again, I'm going to make a new material called just block, and we're just going to make it like a grayish color just so that we can tell our cubes from the ground. Make a few more cubes, mess around with. We can make some parkour if we want. Sky's the limit with this kind of thing, guys. It's like look at this, it's a masterpiece. Alright. Now we've got our nice little obstacle course set up here, whatever you want to call it. We can build our game for like the 50th time today. And now you can see that we can jump around, have a bit of fun. Woo! And the other player is able to see us move around, as you can see. Jump on other player's head. Whoop. Oh, and our player seems to be rotating around strangely. And what you just saw there was another bug where, let's just freeze rotation on the Y too. Let's freeze rotation on all axes for your player controller. That was because our rigid body was actually adding, having force applied to it in a rotation. Let's also set our collision detection to continuous, just so that our players don't randomly fall through the floor. And we want to freeze rotation in the Y because, as you can see there, the player is kind of drifting. And that's it for now.